Hello everyone, welcome back. At this point, we have completed all the hard work. Our agent network assets are published, the broker application is deployed, and everything is up and running on any point platform. Now, we are ready to test our broker agent end-to-end using an A2A 1.0 compatible client. Let's get started. Now, if we open this application, as we discussed earlier, there is no direct public endpoint available. This is by design because the broker is accessed through its managed consumer endpoint. To obtain that endpoint, navigate to the Agents and Tools instance in API Manager. Open the broker instance and copy the consumer endpoint displayed here. We will use this URL from our A2A client to send requests to the broker. Next, because our broker is an A2A compliant agent, we should also retrieve and validate its agent card. If we review the policies applied to the broker instance, we can see the A2A agent card policy. This policy makes the broker's agent card available through its gateway-managed consumer URL. So, how do we retrieve the agent card and identify the skills exposed by our travel planner broker? Let's test that now. Open a browser and paste the consumer URL that we copied from the previous screen. At the end of the URL, append /.wellknown/agent-card.json. The agent card describes what this broker can do and how an A2A compatible client can communicate with it. Under the skills section, we can inspect each advertised skill, including its ID, name, description, supported modes, and example user queries. Notice one important change in A2A version 1.0. The agent card no longer contains a top-level URL property. Instead, endpoint information is represented within the supported interfaces collection together with the protocol binding and supported A2A version. We have now successfully validated the broker's identity, capabilities, communication interfaces, and exposed skills using its A2A agent card. Now, let's test the broker itself. Open Postman, create a post request, and paste the consumer URL here. Under the Headers tab, add content type as application/JSON, accept as application/JSON, and A2A version as 1.0. The A2A version header is particularly important. Agent Network 2.0 supports A2A protocol version 1.0. Earlier Agent Network implementations used the legacy A2A 0.3 protocol, which has different request structures and behavior. Next, open the Body tab, select Raw JSON, and provide the request using the required JSON-RPC 2.0 structure. Make sure you preserve the JSON-RPC envelope, use a unique request ID, and place the user's query inside the A2A message payload. For this test, I'll enter plan a 10-day international trip from Chennai to Dubai and then from Dubai to New York. Find suitable flights for next week. When I send this request, the broker may not complete the travel plan immediately. Instead, it can return a task state input required response and ask the user for the missing information. For a more natural multi-turn test, we should use an A2A compatible client that can preserve the task context and handle the broker's clarification questions interactively. Let's continue our testing through an interactive A2A client. At the time of recording, we cannot test this broker using the standard A2A Inspector. The A2A Inspector is still evolving. Its interactive client currently relies on A2A version 0.3 structures and cannot correctly process the A2A version 1.0 responses returned by our broker. To overcome this limitation, I built a lightweight, custom web application using JavaScript that is compatible with A2A version 1.0. This application provides an interactive chat interface, maintains the conversation context, handles input required responses, and allows us to test the broker with multiple user queries. I'll share this ready-to-use application through my GitHub repository along with the setup instructions. You can clone the repository, configure your broker's consumer URL, and use the application directly for testing your own Agent Network 2.0 broker. Now, let's test our travel planner broker interactively using the custom A2A version 1.0 client. First, let's register the broker in our application using its gateway-managed consumer URL. Once registered, the application retrieves the agent card and discovers the broker's available capabilities and skills. Let's begin with a simple message. Hello. Great! The broker has responded with a brief introduction explaining what it can do. It also tells us what information it requires to create a travel plan, such as the route, travel dates, number of passengers, cabin class, and flight preferences. Now, let's provide a more detailed multi-city travel request in natural language. I'll enter plan a 5-night, 6-day multi-city trip for 3 adults. Travel from Chennai to Delhi on August 8th, 2026. After spending 2 nights in Delhi, travel from Delhi to Hyderabad. Spend 3 nights in Hyderabad and return from Hyderabad to Chennai on August 13th, 2026. The preferred cabin class is economy and any available airline is acceptable. Find suitable flights and recommend hotels in Delhi and Hyderabad. This is a complete natural language request containing the route, passenger count, travel dates, city-wise stay duration, cabin class, and airline preference. Now, let's submit the query and see how the travel planner broker interprets the request, plans each journey segment, invokes the required MCP tools, and generates the final response. Because our flight MCP server is currently using mock inventory, some routes or flight combinations may not contain complete matching data. In those situations, the broker can request additional information instead of generating unsupported results. Now, we have received a more detailed response. Here, we can see the normalized inputs understood by the broker, including the complete route, number of passengers, cabin class, non-stop preference, and flight hold requirement. This demonstrates that the broker is reasoning over the request, dividing the journey into individual flight segments, invoking the appropriate MCP tools in sequence, and requesting user inputs before performing an action such as creating a flight hold. If we continue responding, the conversation can proceed through the remaining flight selections and confirmations until the complete itinerary is finalized. For this demo, however, I'll stop the interaction here. In the next session, we'll apply additional gateway policies to secure and govern the broker endpoint and its outbound connections to the MCP server and LLM provider.